For today's lesson in Unit 2, we are going to look at finding zeros of a polynomial, both algebraically as well as graphically. So building off of what we have previously talked about, it's simple to find the zeros of a polynomial when we are in factored form, and that's what we looked at last class. If it's already in factored form, then I could just take each of these factors and set them equal to 0 and solve for the zeros or the roots, the solutions, the x-intercepts of that particular graph. So I've got x equals 3 and x equals -7. Those would be the two places where the graph crosses the x-axis. If I were to draw just a quick sketch of this based on our last class's information as well, I would have a 0, like we said, at +3, another over here at -7. If I were to multiply this together, FOIL it up, I would end up with a degree of 2 and a positive leading coefficient. So I know my end behavior would be up, up. And the multiplicities on both these binomials is just 1. And so it's going to cross through. So that particular parabola is going to look something like this. And then if we're being precise again, we could calculate that y-intercept by plugging 0 in for x in both of these. And when I do that, f of 0, evaluating this function at 0, -3 multiplied by +7 is -21. So just a rough sketch, this y-intercept would be down at -21. But what we're going to look at today is when we are not in factored form, but rather standard polynomial form, and what are we supposed to do when that occurs. And we'll look at a few examples. So our first example today is a trinomial, and we can solve algebraically by factoring. That's what we're going to be doing today. So this is just as much a review of factoring as it is anything else. Here we're looking at what are the factors of +8 that give us a sum of -6. Some people use a little box method to calculate this, but what we're really looking at is placing this into two binomials. And so I know x will be the first term. When I'm foiling it back together, I get x squared. And then two factors of +8 that give me a sum of -6 would be -4 and -2. So now that I've got it in factored form, I can take each of those factors, set them equal to 0, and solve, and that's how I get my solutions. And when I go ahead and do that, x equals 4 and x equals 2 are the two solutions for that particular polynomial. The solutions, the roots, the zeros, the x-intercepts. And we can check this graphically as well. So I previously did this. I put the function into Desmos, and the two x-intercepts are at 2 as well as 4. The second method we can use when we're factoring would be factoring by looking at a GCF. The greatest common factor here of the two terms is x. So pulling out the greatest common factor x, I'm left with x squared minus just 1 if I divide an x out of -x. And then I'm not completely factored yet because this will factor as a difference of squares into x minus 1 as well as x plus 1. You'll notice that the degree is 3 and I have 3 different factors. So I set each of these factors equal to 0 and solve. My 3 solutions are x equals 0, x equals +1, as well as x equals -1. And again, we can confirm that by graphing. I see the 3 x-intercepts, the 3 roots, the 3 solutions. Example 3 today, again, we're going to be factoring, but this time we have an a value instead of it just being x squared. So there's lots of ways that you can factor this. Typically what I try and do is multiply the first and last term together, and +2 multiplied by -15 gives me -30. Then what I'm trying to figure out are what are the factors of -30 that are going to give me a sum of +7. And in this case, it's going to be +10 and -3. Together, those multiply back together to get you negative 30. But I can also add them and come right back to this positive 7. So I'm basically splitting apart the middle term, and then I copy down my first and last terms, all in line with that polynomial. And now that I have 4 terms, I can factor by grouping. The greatest common factor of the first 2 terms is 2x, and I'm left with x plus 5. The greatest common factor of the last 2 terms is negative 3. Again, I'm left with x plus 5. Because both of the terms in parentheses are the same, that's one of the binomials. And then I take all the leftovers outside of the parentheses. That's the second binomial. So I can take all of these values, set them equal to 0, the 2 factors I have. My solutions will be x equals negative 5 and x equals 3 halves, or 1.5 if you like to write it as a decimal or a fraction. It's totally up to you. Again, the degree of this polynomial is 2. We had 2 solutions. To check that graphically, we can see that this crosses the x-axis twice, both at negative 5 and at positive 1.5. And the fourth and final example for us today is a polynomial with a degree of 3, and we have 4 terms. So our option here would be to factor by grouping. The greatest common factor of the first 2 terms would be x squared. When I divide that out, I'm left with x plus 3. The greatest common factor of the last 2 terms is negative 4, and I'm left with x plus 3 again, dividing a negative 4 out of negative 12. The 2 things in parentheses are the same, so I can group that together as a binomial, and then I take all the leftovers, and that creates the second binomial. Right now, this factored form, I only have 2 solutions, but I know my degree is 3, so that means I'm not quite done factoring yet. I'm going to factor a little bit further on that second binomial. That's a difference of squares, and that factors into x plus 2 and x minus 2. Then I'm going to take all those factors, set them equal to 0, and solve. My 3 solutions are x equals negative 3, x equals negative 2, and x equals positive 2. Again, going over to Desmos, you can type that in and confirm graphically. There are the 3 roots, the 3 x-intercepts, the 3 solutions, all right there for us, the 3 zeros of our function. And that concludes today's notes portion of the lesson. Now you may move into the assignment.